Hello, good day. Welcome to another episode of Learn Smart with Fetola saying. Sorry I've not been posting in a while. It has not been easy. I've been caught up with work here and there, end of the year, beginning of new year, meetings here and there, and it has not been easy. And as a matter of fact, NEPA people have been doing a strong thing recently, and I'm very sure you are hearing the background noise of generator. That's just what I could result into in the end. I just had to do the tutorial, and this tutorial I'm going to be doing it on the fly. I did not prepare a script or anything. Usually I prepare scripts for my tutorials before uploading, so that it's going to flow very well. So pardon me if I don't really flow so well. I'm just recording it on the fly because there's no time to start preparing scripts, and preparing a perfect video anymore. So just pardon this video. Thank you very much. Today we're going to be treating conic section. This conic section is actually a topic that is quite difficult. It might require some diagrams to be able to explain better, for you to be able to understand. But I'm just going to go straight to the point. I won't waste so much of time. Just know what you have to know to get what you have to get. Straight to the point. So let's get started. Before we start with conic section, let's just clear out one or two things. This is a graph, and you have 2 points on a graph like this. Point A, point B. And you're told to find the distance between these 2 points. And I believe you guys should know how to get this. Let's take this first point as x1, y1. This one is x2, y2. So the distance between these 2 points, let's take it as C. You can then say the distance, which is C, equals to square root, I hope you remember, x2 minus x1 square plus y2 minus y1 square. So it's just for us to clear this out of the way. And if you are to find the midpoint, of this equation, then it's actually simple. This midpoint, which is this place, the midpoint of C will then be just the coordinate of the midpoint will then be x2 plus x1 divided by 2, comma y2 plus y1 divided by 2. It's just as simple as that. It's just as if you're finding the average of the 2 points. And then also let's find the slope. Let's also know how to find slopes. Now let's take, for example, this is an equation. Then you have to find the slope of this equation at these same 2 points, x2 comma y2, x1 comma y1. This is A, this is B. Now to find the slope, which is usually written as m, it is y2 minus y1 divided by x2 minus x1. And there are some things that you need to know. If 2 lines are parallel to each other, for example, if I have another one here like this, and you're told to find the slope of this other one, it will still be the same. It will still be the same as the slope of this one. Same thing. It doesn't matter if this one is x3 minus comma y3, and this one is x4 comma y4. It does not really matter. It will still be the same. So for parallel lines, the slope of one will always be the slope of the other one. And what if they were perpendicular? This multiplication of the 2 slopes will be equals to minus 1. There's actually no time to start proving all these things. Just to know them the way they are. Now this is taking us to the first on the list, which is equation of circle. Now equation of circle, A circle, how is a circle actually made? You realize that a circle has two main points, the center and a point on the circumference, and this is usually named radius, right? So you realize that it is the same way everywhere along the circle. If you draw another line like this, it's still a point between the radius and the circumference, which is still another r. You draw it like this, it's still another point between the radius, the circumference and the center, which is still another radius. So we can then derive a formula out of this as the equation of a circle. Yeah, so yes, why not? Let's do that. Okay, so let's take the center of this circle to be a comma b, and let's take this circumference to be x comma y. The circumference is SAP, x comma y. The center is O. Okay, at any point. Now, since we already know that from this, by the time we draw this, let's draw it. I think you should understand better with this. Let's draw it in a graph. Sorry, my circle is not looking like a circle. It's looking like, I don't know. So this point to this point is what we're trying to deal with, which is the radius, right? And we said this point, let's take it as P, which is x comma y, and let's take this as point O, which is a comma b. Right, now we can see that this thing is looking like 2 points along a graph, right? 2 different points on a graph. Now by the time we calculate the distance between these 2 points, then we know that it is the same as the radius, isn't it? Then it has given us a chance to have a formula of a circle. So remember what I said the other time, the formula for finding distances between any 2 points on a graph equals to what? Square root of x minus a squared plus y minus b squared, isn't it? So from here we can then simplify it as much as we can. If you want to follow with the simplification, fine. If you don't, there's no problem. X minus a squared plus y minus b squared. So bringing the square root to the other side, it becomes square, right? Now all we have to do is just expand what we have here. Then we say r squared equals to x squared minus 2ax plus a squared plus y squared minus 2ay minus plus b squared. So all we have to do is just make it look like an equation, isn't it? Just to make it simple, simplified, bring everything to one side, make it equal to 0. So collecting like terms, x squared y squared comes together, these two should come together, that's minus 2ax minus 2ay minus 2b, sorry, this place is b, minus 2by plus a squared plus b squared. Then by the time this r comes inside, it becomes minus r squared, right? Yeah, so everything goes 0. But then let's just try and make this thing as simple as possible, as we can make it. So in order to simplify it better, we can say let g be minus a, let f be minus b, and let c be a squared plus b squared minus r squared. So having said all this, let's just apply them. So we can say the general formula for a circle equals to x squared plus y squared minus 2, since minus is out, it will be 2, it will be plus 2g, then x. So it means this minus a has been replaced by g, isn't it? So it becomes plus gx. Then this minus and this b will be replaced by f. So that will be plus 2fy. Then all of this will be replaced by c, plus c equals 0. Yeah, and I know that you're like, okay, why do I need to know all this? Didn't you say you just go straight to the point? Yes, you need to know it actually, so that you'll be able to understand the shortcuts, you know, how to get it faster, right? Because that's the essence of all this thing that we are going through. So now this is the equation of a circle. For example, this is the equation of a circle. You are told to find the coordinate of the center of the circle. You might be able to find the coordinate of the center of the circle. Find the center. I already know that the coordinate of the center of the circle here is what? A comma b, right? So we need to find a way of getting A and we need to find a way of getting B, isn't it? And find radius. So how do we solve this? You know, for us to solve this, we have to walk it back. It's as if we are back tracking it to something like this, isn't it? But you don't have the luxury of time to start backtracking it to get this, you know. But now you can backtrack, you can get it. You just know that, okay, this is A, this is B, this is R, isn't it? You just know that this is A, this is B, this is R. Then you just write A equals this, B equals this, R equals this. But then you don't have the luxury of time to start backtracking and say you're now bringing back A. You're now there's no time for that. What is the shortcut? Game. Abby, that's what you are waiting for, and why don't I give you? So in order for you to be able to successfully do this shortcut, yeah, you have to put the equation of the circle side by side with the question that you are given. Okay, now you can see these two. They are the same. These two, they are the same, and these two are the same, right? So for us to be able to successfully get what we want to get sharp, since the equation of the circle is still the same all the time, then that means these two will be the same. So 6x plus 6x will be the same as 2gx, which has given us a faster way of getting the answer. Then 2g equals to 6, g equals to 6 divided by 2, g equals to 3, isn't it? You can see, but here it is A comma B, not G. And remember that we said let G be equals to what? Minus A. So if G equals to minus A, then A equals to minus G, right? Then A equals to minus 3. We have gotten the A here to be A for this equation to be what? Minus 3. Now let's get for B. So we can see 8y equals to 2fy, right? Y cancel y. 8 equals to 2f, then f equals to 8 divided by 2, which is 4. Now since we already said it here that f should be what? F should be equals to minus b, then b will be equals to minus f, then b equals to minus 4. So we've known a to be minus 3 and b to be minus 4. How about we get the radius? How do we get the radius? Remember this. We can use this equation since we have almost everything we need. We know that c here is 9, Abi, according to what I did here. C is the same as 9, so c equals to a squared plus b squared minus r squared. C is 9. A here, we've already gotten a to be minus 3 squared, b with minus 4 squared minus r squared, isn't it? So this is 9, this is 3 times 3, 9, 4 times 4, 16 minus r squared. So 9, this is 25 minus r squared, then minus r squared equals to, this comes here, 9 minus 25. 9 minus 25 is 16, right? Yeah, 16. So minus 16 minus r squared equals to, that means r, by the time minus will cancel, minus r squared equals to 16, and if r squared equals to 16, then r equals to what? 4. So we just solve this quickly, and it's because I'm trying to explain, that's why it took me probably a minute to solve. If you see this, you already know what to do. In fact, you can solve, you can get your a and b merely by seeing what you have here. Since you know that this is g, this is 6, then this one will definitely cancel. This 6 will be cancelled by this 2, which is 3. All we just have to do is put minus in front of the 3. That's your a. And the same thing goes here to, this is 8 divided by 2, which is 4. Put minus in front, minus 4, b. You see how I got it in the space of 10 seconds. 10 seconds. So that's the equation of the circle. Anything circle, equation of circle, that's just how to get it. It's as simple as that. Okay, now let's go to the next one. It gets difficult as we go higher and higher. But before we go to the next one, we need to know the normal, equation of the normal and equation of the tangent of any given circle. So let's take for example x squared plus the same question, right, plus 8y plus 9 equals 0. Now this is the circle. The tangent of this circle, is a point that touches the circle, is a line that touches the circle at just a particular point. That point is called the tangent. This point, you just touch it at the point. And the tangent of a circle, tangent from what we already know, is what the same as what the derivative of that circle at that point, the slope of that circle at that point. So it means we are just going to what, differentiate this. Now the question can come this way. So let's find the tangent of the circle at where x equals to 2 and where y equals to 3, for example. So that's the coordinate of the point where the tangent meets the circle is 2, 3, for example. Okay, so like I said, tangent is same as differentiation, right? Let's differentiate this. That will be 2x plus 2y dy dx. Remember from implicit differentiation that we taught sometimes in the past. Then this one is 6 plus 8 dy dx plus 0 cos 0. If you don't know what I did here, please go to check implicit differentiation. Okay, now let's just, all we just have to do is simplify, find dy dx. So 2y dy dx plus 8 dy dx equals 2x minus 2x minus 6. I've sent them to the other side. Then dy dx will then be what? Minus 2x minus 6 divided by 2y plus 8. So all we just have to do is put x and y inside a. Minus 2, 6 minus 6, 2, 3 plus 8. Minus 4 minus 6, 6 plus 8 minus 10 over 14. Yeah, it is 14, right? Yes, 14. So that will be 5 minus 5 all over 7. So that will be minus 5 all over 7 as the gradient. That is the slope of this tangent. Now we already know that the slope of the tangent is what? The m of the tangent is minus 5 all over 7. The question now is, how do we get the equation of this tangent? So from the idea of basic mathematics, y equals to mx plus c is the general formula of getting the slope of any function. we already know that the m here is minus 5 over 7, but we do not know what c is, right? How do we get c? So it's simple. Let's just input what we have here. So that will be y here is 3, the m we already know that is 5 all over 7, and x here is 2, that's x plus c. Then we can easily get c. 3 equals, this is minus 10 all over 7 plus c. Then c will be 3 plus 10 over 7, right? So all we just have to do is simplify and get the answer. So c is 32 all over 7. Then the equation of this tangent is, the equation of the tangent here is y equals minus 5 over 7x plus 32 over 7, and in order to do it better, multiply through by 7. That will be 7y equals to minus 5x plus 32. Okay, so that's the equation of the tangent of a circle. In case you are told to find it, all you have to do is differentiate the equation of the circle given, input the value. By the time you differentiate, you get the y dx, input the value of the tangent that you have there, you're going to get the slope, which is what we did here. And after getting it, input it into this general formula of equation, and just like I did it, and that's that. So the next one is the normal. How do you find the normal of this circle? It's actually quite easy. For you to get the normal, the slope of the normal, you must first know that of the tangent. So the question might go like, what is the slope of the normal and the tangent of this circle? So for you to know the slope of the tangent, the normal of this circle, the normal is just that perpendicular point to this, is this point that is perpendicular to the tangent. And remember we said about the perpendicular lines earlier in this video, the slope of one times the slope of the other will always be what? Minus 1. Remember, so that means we can say that the slope of, we can say that if m1 is the slope of the tangent, then minus will be the slope of the normal, isn't it? So here, so all we just have to do now to get the slope of the normal of this circle, just divide this, divide minus 1 by this. So to get the slope of this normal, that will be minus 1 divided by minus 5 over 7. At the end of the day, you get 7 over 5 by the time you simplify it. So now this is the slope of the normal. And how do you get the equation of the normal? Just follow the same procedure as we did from this point, then you get the equation. It's as simple as that. It's as simple as that. So I'm not going to waste so much of time. Let me go to the next one. Now the next one is parabola. Now I know it is already getting confusing even at the point of the circle. Just stay with me. Just stay with me. Just stay with me. Don't worry. It is going to be fine. You just have to know is how to get the shortcuts. Point out, get the one you want to get and move on. Okay. Now this is a parabola. A parabola looks something like this. A parabola looks something like this. Now a parabola looks something like this. Yeah. This point, let me draw an axis. Now how do we work out a parabola? A parabola is a shape that is formed where any point on that parabola to the focus of the parabola is same to the directrix. I know I've just scattered everything. Okay, but first let me simplify first. This is a parabola, like I said. The parabola has a point inside of it that is called the focus. It's called the focus. It's just like that point where you pin your protractor. What is it called? They use it to draw a circle. The circle. Okay. Now, this is the focus. This place is called the vertex. Now, this line you see in front of it like this is called the directrix. Now, how do we get the equation of a parabola? That's the question, right? Equation of a parabola. How do we get it? From what we know about a parabola, this focus here, if you draw a point, any point P, let's take the P to be x, y. Any point P on the parabola, by the time you find the distance between that point and the focus and that point to the directrix of the parabola, they are always the same. They are always the same. Now let's now draw it on a graph. Let's take, for example, this is a graph. This is a graph. This is the parabola. Let the parabola touch. Let the vertex of the parabola touch the center of this graph. So it goes like something like that. It goes something like this. Sorry, I didn't draw that well. Now let's take this as the focus. Now let's take this as the directrix. So this is a point P on the curve. Like I said, let's take it to be x, y. This is the F focus of the curve, and this is the center of the circle. Let's name this, the distance between these two, let's name it as A. Now that means the focus will be on, the focus is on A for y, but for x, and on y-axis it's on the 0 mark, right? So that means that's the coordinates of the focus. I hope you got how I got this. We named the distance between these 2 points like this, the center of the circle and the focus, we named it A, right? Now it means this point like this is on the point A on the y-axis, on the x-axis, but on the y-axis it's not anywhere on the y-axis, it's on 0 mark on the y-axis. Okay, now this is the directrix. So for the fact that the point distance between this and the and any point on the parabola is the same as the distance between that point to the directrix, so let's name this place any point. Maybe we should just give it D. Now the coordinate of this point here like this, since this, the distance between these 2 points is the same, that means this place also too should be A, but on the negative side, right? Now D, at this point here, we can see that at this point on x, on the x coordinate it is minus A, and on y coordinate it is on the same point as the y coordinate of this, then that's y, right? Okay, how do we now get the equation of this parabola? Since we already said that the parabola, the distance between this place and this place are the same, so we can just use the idea of how to find distances between any 2 points, isn't it? So that would be distance between these 2 points like this, that would be square root of x minus A squared plus y minus 0 squared equals to square root of, now we said that it is the same as these 2 points, so that will be y x minus A squared plus y minus y squared. Okay, so having said this, all you just have to do now is to simplify, but I'm not going to go through the stress of simplifying this. In the end, you get y equals to 4ax. So it means this A here is what, where the focus is, right? The length of the focus to the center of the circle, which is this x is the normal x, this 4 is something that you get along the line while solving this. So this is the equation of a parabola. Now this parabola is when it is along the x-axis, positive side of the x-axis. It is when it is along the positive side of x-axis. So now there are some things that you need to know, that you have to note for this parabola. So if this is the equation of the parabola, then we can say we should also be able to know the equation of the directrix. The equation of the directrix, x is where x equals to minus a, isn't it? You can see it here, where x equals to minus a. That's the equation of directrix. This is the equation of parabola. It is along, you see that it must be going along the x-axis like this for you to be able to use this formula. The formula differs based on the axis that it goes along. Now the length of the lattice rectum, there's something called latus rectum, and the latus rectum is 4a. If it is on the negative side of y, let's take for example it is like this, the parabola is this way instead of this way, then it becomes y squared equals to minus 4ax. That's the equation of parabola. Then x equals to a becomes that of the directrix, and the latus rectum is still always the same. Now what if the parabola was like this? Is along the positive side of y, so that means it is x squared minus x squared equals to 4ay instead. That's the equation of parabola. Now the equation of the directrix will be y equals to minus a. That's equation of directrix, and that of the latus rectum is always the same everywhere, all the time. So you should be able to get for that of when it is the other side, right? You should be able to guess it. What you have to do is put minus, that will be x squared equals to minus 4ay. Then equation of the directrix will be y equals to a, right? So for example, you have a question and you are told to find, this is the equation of the parabola. Now you are told to find the focus of the parabola. Where is the focus? Find the focus, find the latus rectum, find the, what else again can you be told to find? Equation of the directrix, and yeah, let's just say we're told to find this. So like from this now we can see that it fits this equation, right? So we can know that it is on the positive side of x for this equation. So all we just have to do is, just like we said the other time, we don't need to start backtracking, just equate these two. 8x equals to 4ax, x cancels x, then a equals to 8 divided by 4, which is what? 2. So we can see that a is 2. So that means the focus of this parabola is on what? Where a equals to is on 2, 0, right? 2, 0, and the latus rectum is on, the latus rectum is 4 times 2, isn't it? Is 8. The length of the latus rectum is 4 times 2. Then the equation of the directrix, x equals to minus a, right? So that's x equals to minus 2. So that's just how you do it. Though parabola is deeper than this, I must be sincere. This is just the surface of parabola and everything about parabola. This one was plotted based on the fact that parabola is, the vertex of the parabola is at the center. The vertex of the parabola might not be at the center. It might be at any other point of the graph. For example, yeah, this is the center of the graph. This time around, the parabola might plot itself here instead of here, and this might be the directrix, and it's just another ball game entirely. It's another ball game. This time around, it will be a plus a particular length, 0, and you know, it's let's just stop here. I hope I've been able to at least steer one or two things. Just like I said, sorry that it is not very coordinated. I just, you know, did this on the fly. I just want to do it and make sure this is out of the list of things I have to do. And thank you for your time.